The title of presentation today I want to present is non-targeted gas chromatography, Orbitrap, mass spectrometry, quantitative and qualitative analysis of semi-volatile organic compound in indoor dust sample using non-targeted ROI MCR procedure. This project was done in Spain under supervision of Professor Roudabeh. Please go to the next slide. As you know, nowadays most of the people spend their time mostly in offices, houses, working place. It has revealed that indoor dust sample has some contamination which cause dermatological inflammation, asthma, allergy, cardiovascular disease, adverse birth outcome, especially for toddlers. Mostly the source of indoor dust are construction material, plasticized material, paints, electronic, detergent, smoking, exhaust. So we decide to have some more sophisticated analysis for indoor dust sample. Please go to the next slide. We had 3 dust sample. The first dust sample that we call dust 0 was a synthetic dust sample. It contains 58 semi-volatile organic compounds. We made this lab emulated dust sample at 8 concentration level. And after that, we added 5 deuterated polycyclic aromatic hydrocarbon at a certain level as an internal standard. The name of chemical compounds are listed here. Please go to the next slide. The other 2 dust sample was a real dust sample. The dust 1 was a standard reference material, and dust 2 was indoor house dust sample, which is collected by vacuum cleaner. Please go to the next slide. The whole workflow of this study is presented in this slide. First, we analyze our samples with GC Orbitrap mass as a high resolution mass spectrometry, and then we collected data, and after that we imported data to MATLAB environment, and after that we did slicing and augmentation. After that we applied ROI procedure as a method for mass channel reduction and mass compression. In this study we didn't apply any time compression because the number of sample was not too much. And after that we applied multivariate curve resolution to resolve data to pure elution and spectral profile. We used resolved pure mass spectra for identification using NIST library, and we used the peak height of resolved elution profile for quantitation. Please go to the next slide. There are many advantages with chromatographic mass spectroscopy data. The main advantages is simultaneously we can identify and determine multiple known and unknown chemical compounds even in a trace level but the main disadvantages of this analytical method is that high resolution spectrometer mostly produced very huge data, and exportation, importation is very hard, needs special software, and data manipulation or interpretation is very difficult. So please go to the next slide. So we decide to use chemometrics technique for data analysis. The method we used was region of interest, multivariate curve resolution, ROI-MCR. The significant reduction of mass or MZ channels can be done with ROI, and we can resolve all of known and unknown chemical compounds to their chromatographic and mass spectra with MCRLS without any peak alignment nor any peak shape modeling. So we used ROI-MCR, which is a non-targeted tool for data analysis, for identification and quantification of chemical compounds in synthetic and real dust sample. Please go to the next slide. For applying the ROI method, we considered 3 parameters. The first parameter was signal threshold to diminish the noisy mass channel, and the other parameter was minimum occurrence, which is the least time needs to be evaluate a chemical compound, and the third parameter was mass tolerance, which depends on accuracy of mass spectrometer. Please go to the next slide. After that, we used multivariate curve resolution to decompose data into chromatographic and spectral profile. Here, chromatographic profile is elution profile, and spectral profile are mass spectra. Please go to the next slide. The main advantages of multivariate curve resolution method, we can merge or augment as much as possible data set, and we can use for multi-set data analysis, and because of that, after augmentation, we can have calibration as well as real sample elution profile and their mass spectra. Please go to the next slide. The first sample was dust 0. We made at 8 concentration level. This chromatogram is dust 0 at 400 nanogram per mil, which consists of 58 semi-volatile compound in addition of 5 deuterated polyhydrocarbon. For data analysis, we decide to slice the chromatogram in 2 parts, and after that each part augmented, and please go to the next slide. And after that, we applied ROI method. In this table, you can see the parameter we used for ROI method. The number of MZ value was reduced by 473, and 316 for part A 1 and 2 of dust 0. And after ROI, we applied a multivariate curve resolution with this parameter. The number of components identified by MCR was greater than the number of chemical compounds in dust 0, because some of resolved elution profile correspond to background and noise. Please go to the next slide. Then we compare the result of multivariate curve resolution with the reference information, because dust 0 sample includes all known chemicals, so we know the retention time, mass value for each compound. We compared the result of MCR with the reference value. Comparison between retention time and mass showed that totally ROI MCR can resolve all of chemical compounds correctly. However, I should say one of the chemical compound directly has not seen by MCR. I will explain in next slide why this happened. Also, another point is because we did augmentation before ROI MCR, in resolved elution profile, we saw more than one peak. Some of resolved elution profile has 2 peaks, some of them has 3 peaks, and some 4 peaks. I will show in the next slide. Please go to the next slide. One of the resolved elution profile by MCR has 2 peaks but correspond to 4 chemical compounds, because the retention time of 3 of the chemical compounds were very close to each other, and MCR just resolved 1 peak for that, 1 broadened peak for that. Another point, as I mentioned, one of the chemical compound, beta-endosulfan, directly has not seen in the MCR result, because its retention time is very close to PCB 118. We believe that the resolved peak by MCR also correspond to beta-endosulfan. However, the resolved MZ value were very close to PCB 118 rather than beta-endosulfan. Please go to the next slide. After approval of ROI MCR method, we decide to analyze 2 real dust sample, which were unknown sample, and we didn't know their concentration. Because real dust sample are more complex, we decide to slice chromatogram in 4 parts rather than 2. And for dust 1, we had 3 extraction, 3 data set. So we augmented the dust 0 as a calibration set with dust 1 as a real sample to see, are there any known chemical compounds of dust 0 in dust 1? If yes, what are the concentration of these compounds. Please go to the next slide. For dust 2, which was the vacuum cleaner dust, we did the same procedure because it was more complex and it has more peaks in chromatogram. We sliced the chromatogram in 4 parts, and after that we augmented dust 2 with dust 0 at 8 concentration level. However, for dust 2, we had just one data set because of sample limitation. Just we had one extraction from dust 2 sample. Please go to the next slide. As before, first we did a ROI, which their parameter are presented in this table, and the number of resulted ROI value or MZ value are highlighted in yellow. And after that, we applied MCR for resolution. The number of MCR component for augmented data sets of dust 0 plus dust 1 was 177, and for dust 0 plus dust 2 was 76. The more number of MCR component comes from that they are real dust sample, and they include more chemical compounds. Please go to the next slide. In this slide, you can see the result of MCRLS for augmented data set of dust 0. We had 8 concentration level of dust 0. As you see, the resolved peak for internal standard more or less has the same peak height, and all of them overlaid. It shows the robustness of ROI MCR as well as repeatability for GC high resolution mass spectroscopy analysis. On the bottom left, you see the resolution of one peak in elution profile at 8 concentration level. As you see, the peak height are in accordance with the concentration level from low to high. And on the right hand side upper, you see the resolved MCR with 2 peaks, and at the bottom right you see MCR resolved 3 peaks in elution profile, and as before, their peak height are in accordance with the concentration. Please go to the next slide. This slide shows the same chemical compounds for dust 1 augmented by dust 0, and as you see, the internal standard peak height are the same as more or less the same as dust 0. All of and also on the left hand side bottom, you can see the resolved elution profile has these peaks for dust 1 as well. On the left hand side, these 2 chemical compounds also exist in dust 1, and you can see in dust 1 zone these 2 peaks at the bottom, you can see the 3 peaks in dust 1. Please go to the next slide. And this is the result of chemical compounds for dust 2 when we augmented dust 2 with dust 0. Here the concentration of internal standard was less than the dust 0. It comes from matrix effect, and as you see, the concentration of DMP as a one chemical compound in elution profile in dust 2 was very low, and these two on the right hand side upper, these two chemical compounds don't exist in dust 2, and the zone of dust 2 are empty. And bottom right, these 3 chemical compounds exist in dust 2, and you can see these 3 peaks in the resolved area of dust 2. Please go to the next slide. As I told, in real dust sample, we have more chemical compounds than the synthetic sample. Here you can see the resolved elution profile for augmented dust 0 and dust 1 on the left, and dust 0 and dust 2 on the right. As you see, the resolved peaks are don't exist in dust 0. So these are an extra chemical compound in real dust sample. We use their peak height for quantitation, and we used the pure resolved mass spectra for chemimal identification, and with submitting to NIST library. Please go to the next slide. For the non-chemical compounds were identified in real dust sample, we made the calibration curve with the peak height of chemical compounds in dust 0, and after that we estimated the concentration of non-chemical compounds in dust 1 and dust 2. Please go to the next slide. In this table you can see the concentration quantified by Roy MCR were very close to the conventional method, which proved that we can use Roy MCR method for quantitation and also for chemical identification. Please go to the next slide. In this slide, you can see how Roy MCR can resolve the overlapped peaks. On the left, you can see 2 overlapped peaks at different concentration level, and on the bottom, at the bottom, you can see the resolved elution profile by Roy MCR. On the right hand side, you can see the peak cluster consists of 5 chemical compounds, and at the bottom you can see the resolved elution profile at different concentration level by Roy MCR. Please go to the next slide. Okay, this concludes in my presentation. Thanks for your attention. Please let me know if you have any question.